Here we go, 7.4. Adding, subtracting, and multiplying radicals. Here we'll be using a lot of the skills we've developed through 7.3. And let's go to it. How are we going to do this adding, subtracting, and multiplying radicals? First off, we're going to look at what's the square root of 3 plus the square root of 3. Now, you could always find it on your calculator. It's 1.7 something plus 1.7 something is 3.4, 3.5 or something close to that. But what we want to do is actually work with the radicals, kind of like how we worked with x's and y's. So you actually treat this like a term. And square root of 3 and square root of 3 are like terms in a way. They have the same thing under the square root. So we can say, how many square root of 3's you got? Well, there's one of these, and there's one of those. So I got 2 square root of 3's. So you're just totaling them up. You're not messing with the insides. Just like when you add x's, you don't suddenly make it x squared. Adding, you just change the coefficient, the number in front. Likewise, if you happen to be subtracting these two square root of 17 guys, radical 17s, I got 3 of them, then you take away 7 of them. How many you got? Well, 3 take away 7 is minus 4 of these square root of 17s. Notice we don't mess with the square root of 17s. You know, that's its thing. We're just counting how many we got. And what if we come across this? And there's, you know, as it is right now, I can't add those. Those are different stuff. I mean, I can add them by, again, work out each of them with my calculator. But I want to just mix them together, like get them to be like terms, like. So what we can do is, oh, I know, square root of 20's got like a 4 times 5. So that is, I can take the square root of each of those. The 4 comes outside, becomes 2, 5's inside. So I just reduce that, simplified it to be 2 square root of 5. And I'm betting there's going to be a square root of 5 left over here, and wouldn't you know it? That's 100 times 5. What's the square root of 100? 10. With 5 left inside, and now I can add them for a grand total of 12 of these square root of 5's. Cool, huh? Okay, here's the problem for you. You try this. So look at it, write it down, and try it on your pad of paper. All right? So give it a go. Let's see what you came up with. Now, as they are right now, you can't subtract them. I mean, again, you could take the square root of each and get a decimal answer, but we want to like work with the radicals here. We want to keep it in radical form. So can you reduce, simplify them? You know you can. And then, I don't know if you saw that, but if you look at this, oh, that's 36 times 2, perfect square. Wee-ha, yee-ha. So we will take this here, 36. Do the square root of it, since we're taking the square root of each of those things, becomes 6 on the outside, 2 is stuck inside. So if all things go well, we'll find a square root of 2 in the other side, and wouldn't you know it, it is 9 times 2. And this here, 9. Do the square root, hocus pocus, comes outside, 3. 2's left inside. Bring down the minus. Now, what's 6 take away 3? Why? That's 3 square root of 2. Did you get that? Good. If not, pause it, try it again. Look at it over, see if that makes sense. Okay? What if you got a problem like that? Looks a little more complicated. And as they are right now, these just aren't the same. We have 3 of these guys. The x is all like part of the term with the square root. So I got 3 of these x square root of 5x's, and I've got 2 of these. Now it'd be nice if I can get them to look the same. And I look over here, and there's actually nothing I can do with that one. That one's as good as it can go. Can't get down anymore. But check that out. I'm seeing something. I'm seeing that this is 9 times 5. And then I could deal with that x cubed. I know how to mess with that. So, do the square root. Just bring this guy down. And then over here, I'll keep the 2 hanging out here, and it's times, so we'll just bring down the 2. I'm going to take this 9, make it becomes a 3. Mm-hmm. And, and the x cubed here. Oh, I remember that. Because what happens there is you go x to the 3, it's under the square root, so it's the 3 halves. So what does that mean? 1.5. So that means one of the x's comes out, and the other one's left inside. So what's left inside here? The 5, and then one of the x's. So what you get here, when you work that out, everything's being multiplied. Everything that comes out multiplies with the 2, so you get a 6x square root of 5x. Check it out. We got x5, got the same term stuff, and we're adding them up. So 3 plus 6 of these creatures gives you 9x square root of 5x. How's that for something? Whee-oh. Boing. So there you have it. So then next phase, that's the end of this part. We'll go on to the next part. We're going to be multiplying stuff together.